What time are you starting?
4 more minutes. 2:30. People are popping into the Zoom. It says I'm live. So the next thing I got to do is figure out how to get them the link. Last time, most of them went to my channel. Most of them are subscribed. So I just have to type it into the chat once they come.
That's what I would do. Just have one of your students go to the channel, copy the link, and post it for everybody.
Oh, yeah. That's genius. Make them do the work.
Well, that makes more sense than you trying to type it in with all the fucking...
That's what I did last time.
I know, and there was a problem last time, and somebody else had to do exactly what I...
Well, for some reason, the link that I see here isn't the same link that they get when they go to share. It's slightly different. I don't know what the difference is.
Are you signed into any kind of social media on your Zoom computer?
I don't even have Google open on my Zoom computer.
The reason is I can go up there and send you the link, and then you can just copy and paste it.
Okay, yeah. You want to do that? On the Hangouts. I can pull that up real quick. Thank you.
If I can find your channel.
If not, like you said, I can make the kids do it. I cannot hear you. one. Okay. I was just about to let everybody in. What?
Did you get it?
Yes.
Thanks for coming.
I'm sorry. You're right. I'm sorry. I should have told you. Yes, I was able to copy. Thanks. Hi, guys. Just trying to let everybody in. Just give me a sec. There's 2 people stuck in the waiting room right now. I'm going to go ahead and put the YouTube link in the chat so everybody has it. I was able to copy it this time. So I know we need a little bit of time to like figure out what needs to be revisited and stuff, but just so you have it. My waiting room is stuck right now. Sorry. Let's give it a little bit of time. Okay, nobody left in the waiting room. Where'd Jared go to? He's the last one I let in. There we go. Okay, how's everybody doing? Ready for awesome lab collaboration time? Yes. So I know last time was a lot of just kind of deliberating like how to approach this, and hopefully we've done some like thought processing along the way. I actually want to start off by asking a question. Out of the 3 levels, I believe, or the 3 possibilities, the 1-to-1 ratio, 1 to 3, 1 to 4. I think we have enough data to eliminate one of them. Did any of you guys come to that conclusion and want to share those thoughts? Eugene says we can eliminate 1-to-1. I agree. Can anybody explain that, why that makes sense?
We eliminate the 1-to-1 ratio because the delta T, or the delta T, or the change in temperature, was not greatest from the 1-to-1 ratio. It was higher in the range of the 1 to 3 and the 1 to 4, although we don't know exactly which one it was higher for because we didn't have that exact ratio in the levels that we tested.
Do we have enough data to decide between the 1 to 3 and the 1 to 4? So that is your primary objective now, is to kind of narrow that down. The sooner we identify the peak, the sooner we can have a conversation about sufficient data, IB sufficient data. Okay, so what I want to do is just open breakout rooms. I'm going to do the thing where like you can move yourself in between breakout rooms. So feel free to like talk out loud, to direct each other of what breakout rooms to go into or whatever. But I need you guys to come up with like, how am I going to determine whether it's the 1 to 4 or the 1 to 3 first and foremost, and then we can approach the whole sufficient data idea. That being said, dear seniors, I'm so happy to see you guys again. But I did get a little feedback from some of the juniors who hadn't had this collaborative experience yet. And they said the main thing that I was concerned about was they said they like came up with an idea in their individual groups And then the leaders went away, and I'm so glad you brought back the idea of lab leaders, by the way. Super great collaboration technique. But the lab leaders went away, came up with something, came back and said, this is what we're doing. If you could like share with them a little bit about how that agreement was made, that would help them like understand the whole idea of the collaboration a little bit better. Does that make sense? Just try to communicate that a little better. Yes. Okay, so I'm going to go ahead and open up the breakout rooms and give you guys a little bit of time to just kind of figure out how to talk to each other. And I'm going to kind of stay quiet until we have a little bit of a plan that comes from you. I'll make 10 breakout rooms. You guys figure out how to use them.
Do we want to like go back to the groups we had before if we like remember, or? Like I wasn't here for the first one, so I'm not really sure what the groups are or where I should go. So how did you guys split it up last week?
Well, if we have new people, I think we can just do more of a whole group discussion if that's okay with everybody.
Yeah, I think that's probably a better idea because we're missing a lot of people from last time. Like last time we had, I think, 40 or so. Now we only have like 23, so there's a lot of people missing.
Yeah, I just don't think we'd be able to recover the groups without like a significant amount of rearranging and effort. So
Yeah.
okay. Any ideas? So we're looking for trying to get closer to 1 to 3, 1 to 4. We have a total of 50 milliliters, which means we won't be able to get those exact ratios, but we might be able to get close.
I mean, we could probably add like another 5 levels and just like cluster them around like 10 and 40 or something like that. Or whatever it was, like 40, 10.
Yeah, 40, 10, and then what would be the...
So, I mean, we could probably go down and up from 40 in increments of 2 or something. I think that's decently close.
Okay.
So if we did like 36, 38, 40, and then 42, 44 or something like that, like, not sure exactly if that's going to work though.
Let me see. So if we did, that's a good way to test for 1 to 4. Would that include the 1 to 3 ratio?
Yeah, 1 to 3 in the 50 milliliter would be 37.5 and 12.5. So it shouldn't be too big of a problem that we don't have exactly that ratio because we're determining this experimentally anyways.
Yeah, no, that would work as long as it's close. Okay, so as long as it includes both ratios in that range. So in the chat, there was a suggestion to change the total volume to 60. Any thoughts?
I mean, in terms of numbers, that'll probably be easier to do.
It makes the numbers prettier and we don't have to like
Right.
panic around.
Can we just
So
do
instead
that
we
now?
could do like 48 and 12, and I can't really think right now, 15 and 45.
Yeah, we can do that, but we have to just like discard the data that we collected last time.
So, I mean, so would you guys want to like basically redo the whole thing? Because the thing is, I'm not sure we have enough time, so I think that we should use our data and just get more data points.
Well, I think the big reason why we ran out of time last time was because we were deliberating for so long. But if we can actually just solve that within the next 10 minutes, then we'll have plenty of time to collect data.
Yeah, if we just pick it and go with it, it won't take too long, and I think it'd probably be easier to pick levels with 60. So if we want to do that.
So is everyone in favor of starting over? Okay, all right. Okay, let's do it. So what would the ratios be in that case?
We want to start at 1 to 1 so that we have that as part of our new data and then work up towards 3 to 1 and 4 to 1.
Got it.
I think you need to go below 1 to 1.
So yeah, that's true.
Yeah, so those 3 numbers are the most important, and then I don't know what we're gonna do after that. Oh wait, so 45, sorry.
Okay.
So if we did 12, 15, 30, 45, 48, that should be 5.
12. Right. So wait, so if we start at, so we don't need to go,
We need to go below 30.
we need to go, yeah, we need to go below 30, right?
Wait, are you saying, Eugene, are you suggesting for liters of unknown or for liters of bleach?
Probably bleach.
Okay.
So we just need, we need the, so the 1 to 1, 1 to 3, 1 to 4 is bleach first, right? Bleach is the 1? Okay, let me check.
Yeah. I don't have the hand up on it, but I think so. But if bleach is the 1, then
Right, so if bleach is the 1, it's the
you
smaller
would need to
amount. So
go
we just
above
have,
30 liters of bleach.
right, so we just need less than 30 for bleach. So it is,
Make sure we include 12 and 15.
okay, wait. Okay, so I think it's the other way around. So the 1 is the solution B, I think, if I'm interpreting these equations correctly. Does anyone want to check me on that?
I'm kind of lost. Where did you find
The equations are on the lab handout.
Yeah, where did you find that? I'm sure it's somewhere on Canvas, but I can't.
I just had it in my downloads.
Okay,
Want me to share it really quick? I don't know if I have permission.
it's okay. I can find it.
But I think the bleach is the chlorine ion, the chlorine oxide. I don't know how to say that correctly, but I think
I
that's
have a quick question. Because I was here last time, like, you know the mole ratio lab, like the breakout room records. Are you guys working on that document? Because it says at the top, like, it should be shared with your breakout room, or are you guys all just working on separate, like, individual ones?
Don't worry about that document. Let's just worry about finishing collecting data to get to the lab report.
Okay.
So if the ratio is bleach is the bigger numbers. So then it would be, if bleach is first, it would be 4 to 1, 3 to 1, 1 to 1. Okay, just checking. Okay, so then in that case, we need more than 30 for bleach.
Yeah, so start at 30 and work up.
30 and work, okay. So 3 to 1 would be 45.
Would it be wrong to include the ones below anyway, though?
It wouldn't be wrong, but it wouldn't be helpful.
Okay.
Yeah. I mean, we could if we have time.
Let's just go with the above then.
48, 12. That's 4 to 1. Okay. And then so that's 3 levels. So we can just fill in between question mark.
Yeah, maybe add a 40 and then.
There's not a convenient one in between 45 and 48. Should we do? What other levels should we do? We have 4. So we have 30, 40, 45, 48. You guys want one more?
We should do like 46 or 47 or something if in case it's close.
Okay.
47, I guess.
Okay. Do you think that it'll make a significant difference enough to like see anything?
I don't know, but it might help determine the trend.
Okay. I mean, just checking. Okay, so we have 30, 40, 45, 47, 48. Yeah. Anyone have any objections or better suggestions? Should I take that as a we're all good? Okay.
If you can hear me on YouTube, I'm having technical difficulties. Give me just 1 minute.
I totally forgot what we're supposed to do in this stuff. I'm so sorry.
Millimeters, right? Not meters.
I want to just look at
Millimeters, yeah. That'd be a lot of bleach. Good catch.
Yes. Oh, damn it. It's the Demi.
Do we need to figure out anything else other than that?
I don't know, but her silence is indicating that maybe we do.
No.
Okay.
My Zoom is just not working. I was trying to get that lab handout, and I was having like a conflict with the Zoom. I could hear you guys talking, but I couldn't, like, while I was in the file share thing, it wasn't letting me unmute or I don't know. Anyway, so now the handout you were asking for, Vanessa, should be in the chat, and it is on Zoom or on Canvas in a few different places, but there it is, just to be super. Okay. So let me, I'm going to switch to .cam, and I was kind of distracted with the technical difficulties. So if I could get one person to summarize for me, what am I testing?
For our levels of the amounts of bleach would be 30 milliliters, 40, 45, 47, and 48.
Okay, so how about unknown B? In the same order.
30, 30, 20, 15, 13, and 12.
Are we all in agreement? Okay, so I like the idea that you guys are working this out like as a big group, which is fine. I think we kind of simulated the idea of like separate lab tables last time well enough. The thing is, you can't stay in the same room with me and listen to YouTube at the same time. So I need you to pop into a breakout room. I don't know if everybody just wants to go to breakout room 1 or something, because it'll create a weird like audio loop if you stay here. And I will work on doing these. If anything goes out, please somebody come back and tell me, like if the video stops working or something. So you should still be able to get into breakout rooms. I think they're still open, just unassigned, where you can go in for yourself. Does anybody not have an updated Zoom and need to be moved?
I don't have that.
Okay. Pulling up the breakout rooms. So I saw Ava raise her hand. I'll do you first. Who else came in? Jared. Sia. Dylan.
Apparently my Zoom is not updated.
If you, it's up to you if you want to like stay here or go to the room with the kids. Maybe it's probably better if you go to the room with the kids. I don't know.
Oh, okay. Either way, I would think that was true as well.
Hold on. Let's go ahead and get the kids in there and we'll figure that out. Camden, did you need to be moved too? Sorry. Yeah. Okay. I can leave this on, Debbie, and then you would just mute the YouTube and we can hang out in here, or yeah. Okay. It's just like the audio thing, you know. Camden, you should, okay. Okay. All right. So those of you who are not signed into your Learn account on YouTube, if you could chat here, can you hear me on the YouTube? Is the YouTube audio working? Thank you guys. Perfect. Okay, so let's get started then. We're going to do 30 milliliters of bleach and 30 milliliters of solution B. So first, safety goggles. Then we're going to pour 30 milliliters of reagent A, our bleach. Oh, looking at the wrong side of the beaker there. Or graduate cylinder. 30 milliliters. All right, we'll go ahead and put that in our cup. And then we will measure out 30 milliliters of our unknown solution B. So as a reminder to, mostly I guess talking to those of you who missed it last time, we always want to make sure we record the initial temperature first, and then we're going to record the temperature after the reaction happens. That way we can really focus on the heat that's evolved in the reaction. So let me first get you the initial temperature. I'm going to stir this around a little bit. I'm seeing 19.0 degrees Celsius. Level 1, 30 milliliters of bleach is 19.0 degrees Celsius. Since both of these substances have been laying out at room temperature, the same area for the same time, we would assume that is also the initial temperature of our unknown solution B. I'm not going to double check that because it would contaminate my thermometer. Now I'm going to go ahead and mix these two things together, and we will be looking for our temperature at the end of the reaction. Solution B going in. All right, I'm going to read off our temperatures. 19.6, 22.8, 26.0, 26.7, 26.8, 27.0, 27.0, 27.0, and still 27.0. So for level 1, 30 milliliters of bleach and 30 milliliters of solution B, we have a final temperature of 27.0 degrees Celsius. All right. On to level 2. For level 2, we want 40 milliliters of bleach. So measuring that out. Alrighty, put that in our cup. From reagent A, our 40 milliliters of bleach. Now let's go ahead and pre-measure our 20 milliliters of unknown B. Okay, so before I take a new temperature for reagent A, I want to wipe off any contaminants from our last trial. And we're going to take a new initial temperature for our second level, 20 milliliters of bleach to, 40 milliliters of bleach to 20 milliliters of unknown B. That initial temperature is now 18.7 degrees Celsius. 18.7 degrees Celsius. Staying constant. Okay, so I'm going to go ahead and pour in my solution B. And we get 23.9, 28.4, 29.0, 29.3, 29.4, 29.4, 29.4, 29.5, 29.5, still 29.5. Holding steady at 29.5 maximum temperature for level 2. All right, on to level 3. So for level 3, we want 45 milliliters of bleach. Okay, putting that in my cup. And then 15 milliliters of our unknown. Here we go. Kind of hard to reach there. I think I got it. Actually, sorry, a little bit more. All right, 15 milliliters. Oh, first we need our initial temperature. Let me wipe off the thermometer. Okay, so initial temperature for level 3, which is 45 milliliters of bleach and 15 milliliters of solution B. Initial temperature is 18.7 degrees Celsius. All right, now we're going to pour in reagent B. 25.7, 29.4, 30.1, 30.5, 30.6, 30.6, 30.6, still 30.6. So final temperature for this level is 30.6 degrees Celsius. All right, on to level 4. Wipe off our thermometer. All right, so for level 4, we want 47 milliliters of bleach. So I'm gonna be real precise here. Okay, I got it. 47 milliliters of bleach going into the cup of our reagent A. Now for unknown B, we want 13 milliliters. So, and we're going to be real close to the bottom here. Want to be real careful. 13 milliliters. Oh, and I definitely overshot that. Use a little cup. Ten, 11, 12, just a little bit more. There we go. 13 milliliters. 47 to 13, level 4. First, we need to get our initial temperature. Okay. Sorry, let me move this. Okay, so initial temperature for level 4. We've got 18.7 degrees Celsius. All right, so mixing in reagent B. 24.3, 29.0, 29.9, 30.0, 30.2, 30.3, 30.4, 30.4, still 30.4, still 30.4. So final temperature for level 4 with 47 milliliters of bleach and 13 milliliters of reagent B is 30.4 degrees Celsius. So that's level 4. One level left. Level 5. So here we're going to measure just 1 more milliliter of bleach and 1 less milliliter of reagent B. So 48 milliliters of bleach and 12 milliliters of reagent B. So I'm going to be real careful here. Oh, wow. Oops. Let's put you back where you belong before I get confused. Okay, so we're at 45, 46, 47. Let's see, I think I'm there. 45, 46, 47. Man, what I could do with the pipette right now. Just one more little drop. There we go. Let's see. Did I overshoot it? No, that's perfect. 46, 47, 48. Okay, 48 milliliters of reagent A, our bleach, into our cup. And now we want 12 milliliters of reagent B, our unknown. Okay. We're at 11. size 12. Okay. So we got our 48 milliliters of bleach and our 12 milliliters of reagent B. Let me wipe off our thermometer. And let's go with our initial temperature for our bleach. Oh, getting a little warmer in here. This time we're starting at 19.0 degrees Celsius. 19.0 degrees Celsius. Initial temp for level 5. Now we're going to add our reagent B. 25.7, 29.1, 30.2, 30.6, 30.7, 30.8, 30.8, 30.9, 30.9, 30.9. I think we plateaued here. We are at 30.9. 30.9 degrees Celsius final temperature for level 5. 48 milliliters of bleach and 12 milliliters of solution P. There's our first trial of our 5 new levels. If you could go ahead and mute your YouTube and come back to Zoom, you guys can discuss where to go from here. Closing the rooms. It's going to kick you out in like 10 seconds. All right, so the next thing that you have to figure out is what this means. So our original goal was, is it 1 to 3 or 1 to 4? So what do you think we have figured out from here? I'm going to shut up and let you guys try to work on that.
So just want to check on my data really quick. So for the 45 milliliter, we got 18.7 to 30.6, right? Okay.
Yeah.
And for 48, we got 19.0 to 30.9.
Yes.
Okay. Is it just theories that the same amount
Yeah, it is.
difference? Oh God. Okay. So my assumption would be that we need more data.
We could do a trial with just those 2 ratios, right? That way we can determine what the peak is. We don't need to do all 5.
Okay, so just basically redo them.
Yeah. Hopefully one of those.
Well, in order to have sufficient data, you probably want to have 3 trials of all 5 points.
Well, I mean, like,
Yeah, I was gonna say like, oh, ideally we would have had 3 trials for every level to begin with.
I'm sorry I didn't find these earlier. As I was fighting with those last 2 levels, I was like, dang, I need a pipette. I have some. So we can redo things if you want to, or get additional data if you think the last 2 are too close. I can be more precise with these pipettes.
Okay, so should we make any changes to the numbers we decided on, or should we just do like 2 more trials?
Yeah, 2 more trials will sort it out.
If you change the numbers, you're gonna have to do all 3 trials again. So I'm gonna cross my fingers and say that this is experimental error, and we're gonna do, that's the purpose of trials, to reduce errors. So.
Okay, let's give it a shot then.
So what are we thinking?
Adult had brought up a question in the chat. Should we do that? Should we redo the last 2 with the pipettes?
I mean, if we're going to do the last 2 with pipettes, shouldn't we just do all of them with pipettes?
So, okay, so do you guys want to redo the last 2 and then also do 2 more trials?
Ms. O'Neill, was it only like inaccurate for the last 2, or were all of them like they were close?
I'm nervous I'm going to give away a little too much with this, but I do feel like it's kind of my fault. I think your earlier data points are far enough apart that you're going to still get a decent trend line, but with the proximity of the data at the end there, I feel like precision is a little more important there. my 2 cents.
Yeah, we could redo with the pipettes and then just go for trials 2 and 3 from there.
So you want to redo levels 4 and 5 for trial 1 right now? Start there. Okay. So you want to go back into breakout rooms for me to do that? Open. And even if I had to assign you last time, you should still be able to go in now. Okay. Where'd my goggles go? Okay. Are you guys stuck? Can't find the button? Luca and Camden? Luca, all technology working, yes, there will be a recording. Like last time it was able to record straight to YouTube. I was able to post it from there. If not, I will get data just in case. Camden, are you having any issues? Okay, well, let me know if you are, and I will try to help. Okay, let's keep going, guys. So we're going to redo our levels 4 and 5. So with level 4, we wanted 47 milliliters of bleach. So I think I'm going to go to about 45 and then pipette the rest. Okay, so I'm very close to 45 here. 46. 47. I was doing 47, right? Yeah. Okay. So there's 47 of our bleach. Go ahead and put that in our styrofoam cup. And then for reagent B, I'm going to use 13 milliliters. So I'll go to about 10 and then pipette the rest. Keep the pipette separate. Okay. So we're at 11. I'm having a really hard time with this one. 11 is there, 12 is there, 13, so just a little bit more. Okay, there we go. All right, so I've got 47 and 13 measured to a much greater degree of care and precision with that pipette. Okay, let's swipe this off just in case. Can't remember if I did that last time. Let's get our initial temperature for our new level 4 trial 1 is going to be 19.0 degrees Celsius. Okay. So we're going to add our reagent B. 19.1, 27.0, 30.2, 30.4, 30.6. Jumped up real quick there. 30.7. 30.7. 30.7. Still 30.7. I'm going to say 30.7 is the final temperature for level 4. All right. Now we want 48 and 12. So again, I'm going to go to about 45, and then I'll do the rest with the pipette. So I'm a little over 45, but not quite to 46 right now. There's 46, 47. There we go, to 48. All right, we need a new cup. So reagent A, 48 milliliters here. All right, now for reagent B, we want exactly 12 milliliters. So I'm gonna try to go to 10. All right, and now let's pipette. And 11. Actually, almost hit 12 by accident. Just one more little drop. There we go. Perfect. There's 12 milliliters. All right, let's get our temperatures. So this is our new trial 1, level 5, 48 milliliters of bleach and 12 milliliters of unknown B. One second, there we go. All right, our initial temperature is 19.0 degrees Celsius. So now I'm going to add in reagent B. 25.4, 29.4, 30.4, 30.6, 30.7, 30.8, 30.9, 30.9, 31.0, 31.0, 31.0. So I'm going to say the final temperature for level 5 is 31.0. All right, let's come back to the main room and try to figure out where to go from here. Okay, so go ahead and discuss.
So we now have one that's higher than the other, but it's not by a lot.
Yeah.
Yeah, and the 47 doesn't help make a trend.
We watched 3 trials anyway.
It went up, right?
It did go up.
Yeah, it's
It
in
went up by
between.
0.1.
Yeah, but that's it didn't add very much volume. It fits the trend now.
Yeah.
I'm happy with that. I can make a graph out of that.
Okay, I mean, in terms of like uncertainty with the thermometer, would that be within? Because then I don't know if it counts as like definitively higher.
Well, that's why we want 3 trials. It should give us a better idea of like what the actual trend is versus what might just be uncertainty because of the thermometer.
Okay.
So, how did using the pipette influence the uncertainty of the volume difference?
It shouldn't influence the uncertainty of the instrument itself. It just helps you get a more precise measurement within the graduated cylinder.
Okay.
It's harder to go like over, if that makes sense.
I see.
Oh wait, actually, since the 3rd level had a lower initial temperature, didn't it actually have a greater increase in temperature than the 4th level?
No, but that's what we're talking about.
It doesn't
When
go
it's
to
point 1 below.
Yeah, that's unfortunate.
So
I
it's
can
just
redo
really,
that one too. Like, should we redo that one as well? I know it's nice percents, but like, it is really close to 47, 48. We can redo it.
I feel like we might
It's
have
just variability. Just don't worry. I think
Yeah, just move
Get
on to
3
the next
trials
round.
done.
Hope it'll take care of itself.
Excel will do the magic for us.
Okay, so just 2 more trials, see how it goes.
Okay, so before we move forward, do you know if it's 1 to 3? I forget what's first. 1 to 3, 3 to 1, whatever. Do you know if it's 1 to 3 or 1 to 4 right now?
Based off of this, it's 4 to 1.
Are you sure?
Yes, 5.1.
How do you know?
I think we need another trial to determine that, considering the one in between the two doesn't necessarily give us a clear trend.
That's true.
Both kind of peaks, and so we can't necessarily determine that one's significantly higher than the other yet. I think we should do a couple more trials to see where the trend takes us.
Okay, but stick.
For sure. I'm saying like just stop here. I was just basing that off the data.
So the data that you have supports leaning towards the peak at a 4 to 1. So you want to just repeat these exact same 5 levels one more time? That's a yes or no question.
Yes.
Yes. Okay. All right. Back to the breakout rooms. Let me open them. There you go. I'll go ahead and start measuring out the first one. Oh. Ooh. Too much. All right, so that's 30 of our bleach. Good. And 30. Let's see, did everybody make it into breakout rooms? Yes. Okay, awesome. Looking good. So I've got 30 milliliters of each measured out in the graduated cylinders right now. Switch this guy out. So now I'm going to take reagent A, the 30 milliliters of bleach, and pour into a styrofoam cup. And we will wipe off our thermometer and get our initial temperature. So this is trial 2, level 1, 19.1 degrees Celsius. Still getting a little bit warmer in here, it seems like. 19.1 degrees Celsius. Keep in mind, we're interested in how much heat the reaction actually produces. So we're starting at 19.1 this time. Okay, adding in reagent B. 19.6, 26.4, 26.6, 26.7, 26.8, 26.9, 26.9, 27.0, 27.0, 27.0, 27.0, still 27.0. So final temperature for trial 2, level 1. Now let's move on to trial 2, level 2, which is going to be 40-20. 41st here with our reagent A, which we know is bleach. There we go. 40 milliliters there going into our new cup. Okay, and then here we want 20 milliliters of unknown B. Okay. Looks good to me. Try not to touch my jeans. Okay. Initial temperature, level 2. We're back to 19.0. So A little bit of temperature fluctuation. Make sure you record your initial temperatures. 19.0 degrees Celsius. All right, adding in reagent B. 22.0, 28.0, 29.1, 29.4, 29.6, 29.7, 29.7, 29.7. So this seems to be our plateau here. Maximum temperature for level 2, 40 milliliters of bleach, 20 milliliters of reagent B, 29.7 degrees Celsius. All right, now to level 3, 45 milliliters of reagent A. Perfect. Going into our styrofoam cup. And then 15 milliliters of reagent B. Oops. Okay, let me just splashed a little here. And I'll finish this off with the pipette. Going for 15 milliliters. We're at about 13. Oh, you know what? Actually, I'm sorry, I'm misreading this. I went over. Let me pour some out. Okay. So now I'm back to about 10. Now let's go up from here. Not quite there yet. Okay, there we go. 15 milliliters of reagent B. All right, let's get our temperatures. So initial temperature first for level 3. 19.0 degrees Celsius, 19.1 degrees Celsius. Cold and steady at 19.1 degrees Celsius. So the initial temperature for level 3 this time is 19.1 degrees Celsius. All right. Adding reagent B. 24.0, 29.3, 30.6, 31.0, 31.1, 31.1, 31.1, 31.2, 31.1, 31.2, 31.2, 31.2, 31.2. Okay, calling it. Final temperature, 31.2. All right. So I keep track there. So now we're going to do level 4. Level 4 and 5 are real close, so we're going to be real careful. We're going to wipe off our thermometer. Okay, so now we want 47 degrees. So I'm going to get close to about 45 and then pipette. Okay. So I'm actually short of 45, so this will probably take a couple spurts. I'm right at 45 now. So there's 46. There's 47. Okay. So 47 in our new cup. 47 milliliters of reagent A or bleach. Okay, now we want 13 milliliters of reagent B are unknown. All right, so there's 10. Actually, a little under 10. So it's just barely over 10. There's 11, 12, not quite 13, but almost. Okay, there's our 13. Okay. So initial temperature seems kind of high. All right, 19.1. Still 19.1. Okay, so 19.1 initial temperature for bleach. 19.1. Adding reagent B. This is again level 5. 23.0, 28.5, 30.1, 30.6, 30.7, 30.8, 30.9, 30.9, 30.9. Staying steady here, still 30.9. 30.9, final temperature for level 5. All right, that'll do it. Wait, that's not level 5. That's level 4. That's why I have a system. Sorry. That was our final temperature for level 4. We still need to do level 5. My bad. Now for level 5, we need 48 and 12. Slightly different. All right. So we're going to go to 45 first. Close. We're a little bit over. So here's our 45, 46, 47. Actually, already at 47, so I just need a little bit more. Okay, there we go. 48. Okay, new cup. It's reagent A, 48 milliliters of bleach. So now we need 12 milliliters of reagent B. So I'm going to go ahead and pour out 10. It's a little under 10, so I might take a couple squirts, but I want to be careful. Okay, I think I just hit 10. So there's 11. Barely short of 12, like 2 more drops. There we go. There's 12. Okay, so let's get our initial temperature. This time we are at 19.4 degrees Celsius. It's kind of weird that it's getting warmer in here at the time of day, but we have to have the AC off because it makes too much noise, so it kind of makes sense. So 19.4 degrees Celsius starting temperature this time. Staying steady at 19.4. Okay, adding reagent B. 23.0, 28.7, 30.5, 31.0, 31.1, 31.2, 31.3, 31.4, 31.4. Staying steady at 31.4. Final temperature for actual level 5, 31.4. There we go. So we're 2 trials in now. Let's go ahead and come back to the main room and figure out what's next. All right, so feel free to discuss.
So this one we have the same difference of 0.1, but it's leaning towards the other ratio. So
That's a yikes.
yeah,
Okay, so
okay. Adalia wants to redo the third level 1. And I don't think it's a bad idea now that we're realizing we have
yeah, we can do that.
Do
What
we
kind of
use
stare
this
too
right now?
much of a difference?
As time, as we're going on, the initial temperature is getting warmer. So I think if we go back, then it's going to be warmer than 2, or does it not matter because we're just finding a change in temperature?
I don't think it matters because we're just finding the change.
Mm-hmm.
I don't want to send you guys back to the breakout room just to redo one thing though. So give me a little bit more to do.
Okay, so we'll redo that one and then go on to trial 3. Yeah?
Same levels?
Yeah.
Okay. So redo third level would be 4515. Okay, so I'll start with redoing a 4515 and then I will say, okay, now that's the end of the redo. Now we'll start trial 3 and we'll go through the whole thing again. Sound like a plan? Okay. I'm gonna go ahead and start measuring. Let me know if you guys get stuck. It's 45. Okay. Feeling good about that being 45 milliliters. Now let's do 15 over here. Sia, honey, are you stuck? There should be a button at the bottom to click on breakout rooms. It looks like 4 squares. Okay, there's 15. So I got my 45 and my 15 measured. Sia, can you get to the breakout room, hun?
Set that reminder.
Okay, I don't want to hold anyone up. Hopefully we'll have a recording for you if you miss something. So I'm going to go ahead, guys, and start with this trial. I'm splattering a little bit. I'm just going to clean up my workstation a little bit. And I'm going to use fresh paper towel to wipe off my thermometer. And a new cup. All right. So first, region A, we're redoing trial 1, level 3, 45 milliliters of bleach. So that is going to now have a new initial temperature of 19.4 degrees Celsius. Yep, 19.4 degrees Celsius. Now I'm going to add my 15 milliliters of reagent B. We got 27.0, 29.6, 30.6, 31.0, 31.3, 31.4, 31.4, 31.5, 31.5, 31.5, 31.5. Seems to be holding steady at 31.5 degrees Celsius. So that is going to be our new trial 1 level 3. All right. So that was our one redo that we wanted to do. Now, clean slate, we're going to start trial 3. So third run through of the original 5 levels, starting with 30-30. Okay, there's 30. Now 30 of unknown B. Okay, that's looking like 30 as well. All right, so new cup. I'm going to go ahead and pour in reagent A, 30 milliliters. And I'm going to go ahead and get my new initial temperature, which this time is actually 19.5. Nope, sorry, went back down, 19.4. Staying at 19.4. Yep, still 19.4. Okay, so let's go ahead and pour in reagent B. 22.6, 26.5, 27.0, 27.1, 27.2, 27.3, 27.3, 27.4, 27.4, 27.4, holding steady at 27.4. So for trial 3, level 1, our final temperature is 27.4. All right. Next temperature for level 2, not next temperature, next volume ratio. We have 40 milliliters of our unknown bleach. I may have to pour some more here in a second. I think I'm going to make it. Here we go. There we go. Perfect. Actually, I overshot it a little bit. Not perfect. There we go. Okay. So 40 milliliters of our reagent A bleach, and now 20 milliliters of our unknown B. A little bit more. There we go. Okay, so let's go ahead and our new cup, put in our bleach, reagent A, wipe off our thermometer. Let's get our new initial temperature. Okay, we got 19.4 degrees Celsius. 19.4 degrees Celsius. Adding in reagent B. 19.7, 28.0, 29.6, 29.8, 30.0, 30.0, 30.0, 30.1, 30.1, 30.1, 30.2. Oh, back to 30.1. Back up to 30.2. Fighting. Right now it's bouncing back and forth between 30.1 and 30.2. Now it's holding steady, 30.2. 30.2 degrees Celsius. Still at 30.2 degrees Celsius. So we'll call that 30.2 degrees Celsius for level 2, which was 40 milliliters of bleach, 20 milliliters of reagent B. Now we want 45 milliliters of bleach. So I think I'm going to need to pour a little more bleach. Give it a little shake. And refill my mass supply here. Spill a little. Okay. So now 45 milliliters of bleach. Wow, that's actually exactly perfect. Like super perfect. Yay. So now we got 15 milliliters of reagent B. This guy. To move you. All right, now we'll switch over to the pipette. I'm at about 10, 11. Okay. So hard to read at the bottom. So there's 10. There we go. Okay. So actually, I think I'm at 15 right now. I was wrong about being at 10 a second ago. I was a little over. So now I'm at 15. Okay, so now I have 45 and 15 in my graduated cylinder. So now we're going to take a new cup. We're going to go ahead and pour in reagent A. Wipe off our thermometer. And get our initial temperature for level 3, trial 3. Now we are at 19.0 degrees Celsius. Notice what I did right before pouring this bleach. This is why we record initial temperatures. Right now I'm at 19.0 degrees Celsius. This is my initial temperature. So now I'm going to go ahead and pour in reagent B. 20.0, 26.2, 29.8, 30.6, 30.9, 31.0, 31.0, 31.0, 31.0. Still holding steady at 31.0. So that's going to do it for trial 3, level 3. 45 milliliters of bleach and 15 milliliters of reagent B. 31.0. All right, now for those last two tricky ones. So we want 47 milliliters of reagent A. So I'm right around the 45 now. So we'll pipette the rest. There's 46. And 47. All right, now we want 13 milliliters of reagent B. Let's keep everything kind of separated. Bring in reagent B now. So 10, 11, 12, 13. Okay. All right, we'll go ahead and switch to the pipette. just a little bit short still. Okay, there we go. So I've got my reactants centered out. New cup. Oh, I think I already had new cup. New cup. We have reactant A we're going to go ahead and put in here. And then we need a new initial temperature. And this one is also still at 19.0. 19.0. Yeah, initial temperature, definitely 19.0. Adding in reactant B. 26.6, 29.0, 29.1, 29.0, 29.1, 29.2, 29.3, 29.4, 29.5, 29.6, 29.7, 29.8, 29.9, 30. Like 30.0, sorry. 30.1, 30.2, 30.3, 30.4, 30.5, 30.6, 30.7, 30.8, 30.9, 31.0. I think we might have hit the plateau. Nope, 31.1, 31.2, 31.3, 31.4, 31.5, 31.6. Can't believe it's still going up. 31.7, 31.8, 31.9, 32.0. Back down to 31.9. Still at 31.9. Still at 31.9. So I'm gonna let you guys figure out what the final temperature should be on that one, since it kind of popped up for a second and then went back down. You figure out what to do with that. On to level 5. So the 5th level is 48 milliliters of bleach and 12 milliliters of reagent B. So there's roughly 45. $46, $47. A little more. There's 48. Now we want 12 here. For reactant B or reagent B. Oh, I went a little over 10. Actually, I'm right in between 11 and 12 already, so I don't need much more. Okay. So there we go. We have our reactants measured. Let's go ahead and put reactant A into our cup. Wipe off our thermometer. Get our new initial temperature, which again seems to be 19.0 degrees Celsius. All right, so since we're at 19.0 degrees Celsius, let's go ahead and add in reagent B. 21.4, 25.9, 28.0, 28.8, 28.7, 28.8, 29.0, 29.1, 29.2, 29.4, 29.6, 29.7, 29.8, 29.9, 30.0, 30.0, 30.1, 30.2, 30.3, 30.4, 30.5, 30.6, 30.6, 30.7, 30.8, 30.9, 31.0, 31.0, 31.0, staying constant at 31.0. So we'll call that on level 5. Final temperature for level 5, 48 milliliters of bleach and 12 milliliters of reactant. All right, so now we have 3 trials, 5 levels. Let's come back and see what we think now. There are a lot of important decisions that need to be made right now, so Ms. Dylan and I are going to stay out of it and leave it to you guys.
In comparing trial or levels 4 and 5, for this trial, I think for the final number for level 4, I said 31.9, but that would make it a bigger difference. And I'm not sure if we want that then at level 5. So I don't know if it was going up and down for that one. So what did you guys have a different number for the final temperature for level 4?
Anyone got input on level 4?
I don't know, because our options are 31.9 or 32.0. So like we should like manipulate the data to like change it or whatever, but 31.9 does make our difference like better.
It's still greater than level 3 and 5, which is different than the first 2 trials, so I don't think it matters that
Right,
much.
I don't think it matters, to be honest.
It's just going to be an outlier no matter which number we go with.
Exactly.
Okay, that's okay. Thanks, guys.
Speaking of, this trial was a bust.
Yeah, so the other 2 trials showed that our like level 3 would be the best ratio, but this one they like tied.
Mm-hmm.
They have the same like change in
They're
temperature.
the exact same change.
We did a greater like total volume. Would that make the temperature differences greater because there's more reactants?
I
When
think.
did they change the volume?
I'm just
What do
saying,
you mean?
if we did change the volume, would it like make it so that we didn't have such close change in temperatures?
You mean if we had a bigger total volume?
Yeah. I mean, I don't know. We can't like make any conclusions from this data, though, so you kind of have to, right?
We can lean towards level 3.
Because we have 2 trials that like
Yeah, we have 2 trials. But it is very close.
Like my only problem with making that conclusion is that it's like the uncertainty of the thermometer is 0.1. So it's like if it was outside of that, it'd be pretty fine.
Yeah, that's the concern. We don't exactly have enough time to redo the whole thing with a bigger volume. So,
would adding a trial like past level 5 help? Like if we just added like 1 more level, would that help show that like the level 3 is the highest?
So what's the argument for trial 3 supporting 3 to 1?
Well, it had 2 delta T's of 12.1 and 1 of 12.0, and no other level had anything higher than 12.0. So technically, it does have the most. It did give off the most T, but it's within 0.1 of level 5. But level 5 didn't have any 12.1s. So technically, you could argue that level 3 gave off more T.
Okay, so we just need to figure out. Okay, so Ms. O'Neill's offering to give us extra data, so we just decide on a peak. So 3 to 1.
Yeah.
Okay. So 3 to 1 will be a peak.
Oh no.
I feel like what we should do is we should increase the total volume to 80, and then we should just test the 3 to 1 and the 4 to 1 ratio, and then that way we can hopefully we'll have a greater
I have
change.
time for that, and then we have to like redo all of our other like values too, right?
Yeah, I don't know that it would be I don't know what the word I'm looking for, but I feel like it'd be a bit strange just to have the 2.
Mm-hmm.
Well, because all we need is to determine a peak, and then once we have a peak, we can set up data points and then set up data points that have a nice graph. You know, we don't need like.
But if we're using a different total volume, can we even put it on the same graph? Is that
No, we can't because it's no longer a control.
exactly?
Well, I'm saying that we wouldn't use. I don't really think we can, because anyways, if we did choose a peak, then we'd have to get more data, right? For the 3 to 1, we'd have to have 5 data points on that first line.
Well, she's giving us
to
more.
1,000 units.
Once we choose the peak, she's giving us some more data for that.
Also, assuming the fact that she put a frowny face in the chat means that we're wrong, and therefore it's the other one. So I feel like at this point,
I mean, if we
Justify
want to redo something, if we want to redo something, we should probably redo the ones that make it not make sense
but
until.
we've already redone those ones and got data that like proves the other way.
Yeah, I mean, we redid the trial ones, but if you like really want to do something, we can definitely redo. We have enough time, I mean, to do like redo the level 3 for trials 2 and 3, I guess.
I mean, yes, but I'm also feeling a creeping sense of like, is it gonna help? You know, we've redone. We've tried the tactic of redoing. I mean, it's an option. I'm not denying that at all. I'm not sure if I don't know.
I agree. I don't think redoing level 3 would be helpful. We've done that enough times.
Okay, well, okay. Let's go with doing the 80 then. I mean, just to, I don't know, maybe get 2 data points just to find a peak. And I'm not entirely sure what we would do with the data after that point, though.
Yeah, I was just about to ask Kelly's question, like, how do we put that in the lab report?
Yeah.
I don't get your question, really.
Okay, say we make the argument using this new data that the peak is 4-1 because this data corresponds to that. How do you incorporate this data into the lab report, but not into the graph?
You could still use the data that you have. This 80 could be a way to help us determine what the peak is and help us figure out how we want to interpret the data that we already have.
Yes, but if we make a conclusion based off of data we don't include in the report, like formally, how can we argue that our conclusion is correct?
Well, no,
We'd have to figure out how to argue it based off the data we have. But once you know the answer, that might be a little easier.
So if we like use the 80 and then we get it leans towards like the 4-to-1 ratio, then we would just use like that.
I mean, but then what's the point of doing the 80 in the first place if we know the answer is 4-1? We would just have to.
We have to prove it somehow.
But we can't prove it. We're not including these data points.
Right, we have to include it in order to prove it. So
Yeah.
we have to include it in the report somehow.
So if we don't include it in the report and we just do the tests, but we use these data points to argue our point, but we don't include it in the lab report, there's no point in doing these data points.
Well, just because the data points wouldn't prove the conclusion that we're saying we're making. There's no way that we can just manipulate the data to go our direction, you know?
Yeah.
So how about, okay, so maybe we can just do the 80 to see if we get the right one. And then, yeah, just put it in the report, but maybe not in the graph. Okay. Worth a shot.
Okay, we are kind of running short on time. We're getting close to, it's already 5. So let's go ahead and try this idea. Like I feel like it's a good idea to test your 3-to-1 and your 4-to-1 so that we can get an idea of where the graph is. And then we can have what I think is the most important discussion out of this entire process. How do we now get sufficient data to prove our point? So let's go ahead and pop in the breakout rooms. I know I said I didn't want to go back for 1 point, but just time sensitive. Let's do that real quick and then pop back. Oh, actually, Dylan, hang out for a second. I missed what actual volumes you said to do of each one.
Do 60 milliliters of bleach, 40 milliliters of the unknown, and then do 64 milliliters of bleach, and then 16 milliliters of the unknown.
Okay, 16. Okay, so 2 levels. Got it. Thanks. Okay, so it looks like we're doing 2 levels here. First, the actual 4-to-1 ratio with bleach to B, 60 milliliters of bleach to 20 milliliters of unknown B. This is gonna make a mess. There we go. I'm a little bit over. All right, there's exactly 60. And then we want to do exactly 20. Unknown B. Okay. That's a little over 2. I'm not going to be able to pipette that out. Pull a little out and pipette back in. I think I poured way too much out. Now we're at 15 milliliters. There we go, getting close. Okay, top of the meniscus is at 20. There we go. So now we've got 60 milliliters of bleach and 20 milliliters of unknown B. We're going to put that in a new cup. There we go. Let's wipe off our thermometer because I can't remember if I did that last time. Get our initial temperature. I got 19.0 still. 19.0 degrees Celsius. So I'm going to go ahead and pour in solution B. 22.0, 28.6, 30.0, 30.7, 31.0, 31.0, 31.0, 31.1, 31.1, 31.2, 31.3, 31.3, 31.3. Staying steady at 31.3. So 31.3 is our top temperature for 60 milliliters of bleach and 20 milliliters of unknown B. There was one other ratio that came up, 64 milliliters of bleach to 16 milliliters of unknown B. So first our bleach. Okay, so I'm right around 60. I'm going to do the rest with the pipette. And close. There we go. Yep, 64. Got our new cup. So there's our 64 milliliters of bleach. And here we want 16 milliliters of unknown B. Oops. Again, I did too much. Goes so fast. Okay. So I'm back down to a little under 15. Right at 15. Okay, there we go. 16. All right. So let's get our initial temperature. All right, so initial right now is still 19.0. So 19.0 degrees Celsius. Pouring in solution B. 19.5, 26.3, 26.6, 28.1, 28.4, 28.5, 28.6, 28.7, 28.8, 28.9, 29.0. I went up fast. 29.1, 29.2, 29.3, 29.4, 29.5, 29.6, 29.7, 29.8, 29.9, 30.0, 30.1, 30.2, 30.3, 30.4, 30.5, 30.6, 30.8, 30.9, 30.9, 30.9, 31.0, 31.2, 31.3, 31.3, 31.4, 31.5, 31.5, 31.5, 31.6. Deceptive plateaus. 31.6. Still 31.6. This one seems to be climbing slowly, so I'm going to give it a little bit of extra time. 31.6 still. 31.6. Okay, I think we're good. I think we're staying steady now at 31.6. So final temperature for 64 milliliters of bleach and 16 milliliters of solution B. All right, come on back. Let's see what that means.
Well, at least now it's clear.
Are we allowed to disregard the redos we did and stick with our original trial one? Because if we do that, then it leans towards like the 1 to 4. and then we have one that leans towards 1 to 3, and then we have one that ties, which would justify us using the other one, if that makes any sense.
Wait, do you mean like the very first trial that we did like 2 weeks ago?
No. The like first trial that we did today, and then we redid 3 through 5 because we didn't have a like pipette.
But then isn't that, I see what you're saying, but doesn't that like remove one thing from control variables?
Yeah.
Teacher thing?
That's
And
what I was.
also, our reasoning for that would then be we use less precise measurements to make the data, to skew the data towards where we wanted, which would not be good. So that probably would.
Yeah, no, you guys are right. I was just bringing it up to see if it was like an option. Okay, so if we're not overthinking the pipette thing, then we can disregard our redos. And it works.
Yeah, I think that's alright.
If I'm being what it sounds like to me is I personally disregard the redos to use the good data. It sounds like maybe since there's teachers in the Zoom, we're trying to do like the perfect sciencey thing, but to do what works with the data. Just saying.
Does that sound good with everyone?
Yeah, I think that's alright.
So let me ask you this. Is it crystal clear now whether it's a 3 to 1 or 4 to 1? Which one do you think?
4 to 1.
Okay. I'm going to switch to DotCam and kind of sketch something out. And then I want to ask you about what do you think we have in terms of sufficient data? So let's think about the graph that we're going to need to make, right? We need to kind of talk about our independent variable. What are we changing on purpose that would go on the x-axis?
Volumes of bleach in solution B.
Very good.
And you'd have 2, I think.
Yes. Yeah, and you have to insert it as a text box to have a separate x-axis. So let's just go with whichever one was increasing. Which one was that? The bleach that was increasing? This one too? Okay. So let's say we're sketching out the volume of the bleach in increasing milliliters. Okay. What was changing in response to that?
The final temperature.
Change in temperature.
Yeah, I did have to calculate change.
Okay. So something about the temperature. I'll let you guys make your final decisions on there, but you have some good ideas. And the idea is we need to be able to find our peak. That's what we've been focused on. Is it 4 to 1 or 3 to 1? So whatever the numbers come out at, let's say we have our 4 to 1 ratio. What would constitute sufficient data? How could we prove it graphically? We talked about graphing an increase and a decrease. Sorry, somebody just started to talk. Go ahead.
I was going to say, like, the highest change in temperature is going to be, like, the best ratio or, like, the ideal ratio. So, like, whatever the highest point on the graph is. Yes.
I mean, you'd probably make a trend line using all the points, including the peak and the left of it, and then a separate trend line for the peak and points right of it, and then finding their intersection.
So you're talking about having 2 separate trend lines, one that shows the increasing and one that shows the decreasing, like 2 separate trend lines.
Yes.
So how
Would that mean
many?
that- Don't we need then, like, trend line requires 5 points then, so would that mean 9 total points that we need?
You're absolutely on the right track of my question, but I need you guys to come up with the answer and then I'll supply the data. I'm going to stop talking. I want you to discuss this.
I think we need 10 total points instead of 9, right?
Well, if they intersect at a specific point, then we only need 9. But if they intersect like in the middle of 2 points, then we would need 10.
Yeah, I think 9 is okay because then each trend line would have 5 because they should intersect at one point. So
Yeah, I agree.
in terms of having 4 data points on either side, could we count the 60, 0 and 0, 60 as 1 on each?
Yeah, I would say so.
Yeah, you should
Yeah,
be.
she said that we needed to have that. Like at some point, she said we should have that.
But we can't count it on the like left side. Like we can't set it as like a y-intercept. It has to be like
It have to be 2 points.
right. Like it'd have to be like past the peak. That makes sense.
So we would have, okay, so then on the left side, we would have 0, 60, right? Wait,
How would the trend line look if we put in 0, 60 and 60, 0? I'm just wondering because I'm curious.
It'd be like 0 milliliters of bleach, and then the change of temperature would be 0. And then for the 60, 0, it'd be 60 milliliters of bleach, and then 0 change of temperature.
They are both valid points, data points.
right,
So
so
you should be
then,
able to include them.
okay, so then in that case, do we just need like 3 tested ones on each side?
I think we should do 5 on either side because I know that technically makes the trend line with 5 points, but since it's like the peak. It does count as a level, right?
Well, can you really count it as a level? Like if well, actually no. What would you test? Does it count as a level if you didn't test anything? But I mean, like on the other hand, what would you test for something like that? If it's
I mean, you could put 60 milliliters of one reactant in a thing and take the temperature, but you would know what the result is, so I don't think there'd be much point in actually doing it.
So for the sake of time, let me go ahead and resolve that question. Yes, I had said about that. We talked in the demonstration about how including 0, 60, 60, 0, or whatever you guys ended up with using, or use 60, to include those to show that when there is an absence of reactant, that you have no product is a valid thing that you should include on your graph. However, it is not something that counts as a level. It's not an experiment. It's not experimental data. It's the equivalent of setting your y-intercept. And no, setting your y-intercept does not count as a 5th level. Does that make sense?
Does that mean that it's not a 5th level, but it is a 5th data point?
It should be, I guess, essentially a 6th data point.
So you need to have 5 other data points other than that?
Correct. And the other point of contention that you guys didn't quite resolve, and I encouraged Dahlia to speak up on purpose, was whether or not having the intersection as a data point is valid. Can you use the same data point on 2 different trend lines? So talk about that just a little bit more.
I don't know, this might be wrong, but like I think you can because it's like you're comparing like that point to the other points as well. So like since you're comparing all of them using the same point twice shouldn't change it, right?
If both trend lines are for the same trial, then I think it should be okay.
Like,
I think
what
that it
reason?
needs to be included. Like, you can't just have 4 on each line. It needs to be like you need to have 5 points. So like on each trend line, there's the point, and so they'll intersect. So it'll look like one anyways. Or instead of doing that, we could just do like 5 points and have on one of the trend lines, like the peak be that point, and then on the other trend line it has 5 points that are not peak.
5 different ones.
Yeah.
Yeah, I mean, I don't know if there's like a specific reason. I'm not sure if there's a specific reason why you couldn't use the same point on 2 different trend lines. But if we can't, then we could do the intersection is a point on one trend line and then just exclude it from the other and then have 5 different ones.
But if we did that, then wouldn't we have to give reasoning as to why we included it on one trend line and not the other?
Good point.
Yeah.
That is a good point. I hadn't actually thought about that one before. What is the point of a graph? To experimentally determine what?
Like, are you saying in this specific lab, or like what is the point of a graph in lab?
No. In this lab, like in this lab, every lab has a graph to prove a point. What is the point of having this graph in this lab?
We're looking for the mole ratio of the reactant, which would tell us the unknowns that we need.
Very good. Remember, graphing in general is a way to 2D average your data. We are trying to experimentally find an average intersection. Not one specific data point, but a trend line intersection. So no, a data point cannot be the peak. You need 5 points on either side. Does this make sense? Okay, we have about 6 minutes left. If you can suggest to me what different levels we would need, then I will come up with data that may or may not exactly match what you come up with, but I want to know that you can come up with a viable plan. Okay. So what levels would we do?
Okay, so we have the ones like we tested, right?
Yeah, so we just need to find some more. So on the left, we have 30, 40. We have a lot on the left. We just don't have any on the right. So we have 30, 40, 45, 47. Can we count the 48 on one of the trend lines?
No, because it's an intersection, right? Didn't she just say we need 5 on each side?
Yeah.
Right. Okay, so then we would just exclude it?
Yeah, like for the purpose of finding levels, yeah.
Yeah, because it's just finding different levels.
Probably won't actually be the peak.
Okay, so then we have 4 on the left. We have none on the right. Okay, so that makes this work.
Should we try to make it like around even? Like in terms of intervals?
Or do we just test other ratios, like 1 to 5, 1 to 6, that kind of stuff?
I can pull up a document. Hold on. Okay, let's work. Okay, so we have 30, 30. This is bleach first, by the way. 40, 20. 45, 15, 46, 47, 13, 48, 12. This can't count on either one. We have 4 on the left. Anyone got a suggestion for just one other one? Should we go below?
Just for like a nice one on the left, you could do 35, 25.
Yeah.
Oops, that's in the wrong spot.
I don't.
Okay. Okay, so how about on the right? We don't have a lot of space, so the intervals are gonna have to be smaller. We have up until like before 60. So we could do 50. Maybe split
If you increment by 2, you'll make it. Yeah.
Okay, that's 5. Okay.
Yeah, that's perfect actually. Because we can't include 60 0 as a data point.
Okay. So is this good with everyone?
Mm-hmm.
Okay. Okay. So I took a picture. Oh, I'm still on DocCam. You can stop this picture, Evelyn. Thank you. Where's my live camera? Okay, I agree that those suggestions seem like they should work. I took a picture of what they are. I'm going to comb through the last couple years' data and try to get as close as I can to what you came up with. I have done the 4-to-1 ratio before, so I should have some data that's very close to this. I will send it to Ms. Dolenshire and post it on Canvas for my kids like by tomorrow afternoon at the latest. Okay? Any questions, Camden?
Are we going to class next class? Like, do we have class if we were here next class still?
Yes, yes.
Okay.
You have notes. Any other questions, guys?
If we needed help making the graph, would we need to come up with like a separate set of data, or can we get help like with this specific set of data?
So I can't like walk you through literally plotting the data that I give you. That would be like helping you too much on your practice IA. But I can show you the mechanism of how to use Excel using random data that I make up from something else, just like random other numbers. So, and that's something, by the way, Camden, that I wanted to do tomorrow. So one other thing I wanted to mention for my A-Day kids is if you want to come to the B-Day time tomorrow and you're off cohort, if you have any questions on the graph or want to kind of see me go over it, I can. I know we didn't have a lot to talk about today. All right, any other questions, guys?
Is there anybody from my class who doesn't mind putting the data from tonight into page 2 in like not a pretty way?
I can do it.
Can you do that, Maria? Thank you. Yeah, I just started it how Honest listed it from day 1, and then if you can just, I started putting stuff in there that I thought was in the chat, but if you can just list it, that would be awesome. Thank you.
Maria, do you mind sending that to me too for my kids that aren't here too?
Do you want me to just email it to you?
Yes, please. That'd be perfect. Okay. Anything else, guys? Any questions about what happened? Did you guys have fun? Good. I know it was a little challenging and mixing stuff doesn't seem super exciting, but this whole like trying to figure out what the heck is going on, I hope is fun. So, all right, guys, it's been fun. We'll try to do something like this again soon.
Thank you.
Thanks.
Thank you.
All right, thank you.
Thanks.
Thank you.
I don't know.
The juniors are really cute. I like them.
They are. They're really smart.
Let me see them.